Hello, everyone. Welcome to part 5 of our Python series. So in today's lesson, we'll be talking about decision making, which is a very fundamental aspect of Python and all programming languages. Just to recap, last week we talked about lists and started talking about user input. So today we'll do a very brief review of that before we jump into if statements. So far, the code that we've been writing, we've been declaring our own variables inside of the code. And in real applications, sometimes we want the user's input. So that's what the input function does in Python. So when we run something like this, where we're setting a variable equal to an input function, essentially we're assigning that variable to whatever the user inputs in the format of a string. So because this function only returns a string, even if you're entering something that's a number, for instance, and you want to use it as a number, casting types is something that's very important as well when we're dealing with the input function and also converting between different data types to use them for different purposes. So over here, we see that whenever we want to try to cast, it's the technical term is cast. When we want to cast a string to an int, we just wrap our variable around with the int keyword. So this is just brief review. Now we also talked about how Python, one of the core principles is indentation, and that's how we specify the different code blocks. And we'll see that a lot today when we're dealing with if statements. Does anyone have any questions up to here? Okay, if not, then we'll move on. So the if statement is used to make decisions. So first, we have the if keyword, followed by a condition. Now, this condition is always going to be a boolean, you can think of it as. So a boolean is a binary variable with only two states, true or false. And we check that boolean. If it's true, then we execute the code inside of the block. So to specify where the block starts and ends, we use a colon right here, followed by any code that's inside the block with an indentation. And this code outside, we can see very clearly this is outside of that code block. So we talked about some of these examples last time, and also some of the very important operators. So those would be like the comparison operators, which would be equal to, greater than, or less than. So I'm going to stress it again, but checking equality is two equal signs, whereas assigning a variable to a certain value only uses one equal sign. Okay, now let's talk about some logical operators. So we just talked about comparison operators, but there's another category of operators known as logical operators. And these are used to make more complex decisions that can rely on multiple different statuses and booleans. So they're used to combine many different conditional statements together. You can write as many conditions on a single if statement as you like. And depending on the logical operators we use, the if statement may or may not run. So let's look at some of the logical operators, and there's three. So the first one is and. So we have an example here. Can we play outside tomorrow? And we can play if it is sunny and you finish your homework. So in order for us to be able to play, we need to satisfy two conditions, both it is sunny and you have to finish your homework. So the logical operator ensures that when you check multiple conditions, both sides of the condition are true. So that means we have to be able to play, if we want to play outside, it has to be both sunny and you have to finish your homework. If any one of these is false, then the whole thing is false, meaning we cannot play outside. Does anyone have any questions? Okay. So here's what this looks like in code. We have three variables, x, y, z equals 5, 10, and 6. So by the way, if you haven't seen this kind of syntax before, this is how we can declare three variables in one line. So essentially, x is set to 5, y is set to 10, and z is set to 6. So we have a condition here. If x is less than y and x is equal to z, then we print both statements is true. Now, does someone want to answer what do you think it will print? Or you can type it in the chat. Okay, some of you said error and false. So you're right that the condition is false, but I asked what we're printing out. So actually, we're not printing out anything. But yes, if you said this is false, you are correct. Also, this technically would not result in an error. It's just this condition is not satisfied. So if it's not satisfied, we do not run the code inside of the block. Does that make sense? And also, another thing to mention is that when you use if A and B, if the first one is false, then we automatically do not evaluate the second one. This is just something Python does to save time. But in this case, x is indeed less than y. So the first part is true. But x is not equal to z. We have x equals 5 and z equals 6. So clearly 5 and 6 are not equal. So this is false. So since one of them is false, the whole statement is false. But we changed z to 5, for example, we will have a print output. We will get both statements were true. Okay, nice. So something else is that you can actually use you can use several and statements together. You can chain several of them together. For example, and what's a good example here? And let's say x plus y is less than 20. So you can have multiple of these and statements together. And similarly, if any one of them are false, the whole thing is false, and we won't print the statement inside. So now we have another logical operator, which is OR. So here's an interesting example. Can I have a new iPhone? Only yes if you pass your math competition or you get a 1600 on the SAT. So what this means is you can get a new phone if either of them are true. So only one of them needs to be true in order for you to get an iPhone. You either pass your math competition or you get a 1600, which is a perfect score. So if one of them are true, you can get a phone. And if both of them are true, that's even better. You can also get a phone. But if none of them are true, then that's too bad. You're not getting a new phone. So here we have the OR logical operator is used to check it for one or both conditions to be true. Such that if the competition, if the, not competition, if the condition on the left is false or the condition on the right is true, basically if the first one's false, the second one is true, or if the first one is true and the second one is false, it will still run since one of them is satisfied. So similarly to the AND statement, if the first condition is true, then the second one is not evaluated. So here we have an example using code. It's the same example. If x, y, z equals 5, 10, 5, and if x is less than y or x is not equal to z. So exclamation equals, this is basically not equal. It's the opposite of two equal signs. Print one or both statements were true. I think the answer was already revealed here. Yes, so x is indeed less than y. And x is not equal to z would be false because they are equal. But since the first one is already true, it will still print this statement. So as you can see here, x less than y and x is not equal to z, these are both logical operators. Not logical operators, they're both comparison operators. But comparison operators themselves are actually a boolean. So as you can see over here, you can actually directly put booleans in here. So we have condition 1 equals false, condition 2 equals false, condition 3 equals false. And we have this over here. So you can actually directly have booleans. So this example over here is trying to demonstrate the order of precedence, or you can think of it as the order of operations for Boolean logical operators. Here we have or, and. So we have multiple logical operators here, but which one do we evaluate first? So in Python, the precedence would be first is not, second is and, third is or. So first we have not, second we have and three we have or. So that means we'll always evaluate not first. Remember, not is the exclamation. Or actually I think there's a not keyword. But then we do and then we do or. And sometimes you can also use parentheses, just like in math, like we have PEMDAS, the order of operations. You can also use parentheses to explicitly declare the order. Yeah, so then we have here the not keyword. So the not keyword is the most straightforward. It simply negates or it basically flips the value. So if it's true, it becomes false. If it's false, it becomes true. So it basically just checks the opposite of a value. Yeah, so it essentially returns the opposite of whatever the current value is. Is this clear to everyone? Okay, so you can learn more about these logical operators in our ACSL contest. We have lessons of those on YouTube. In Boolean algebra, we literally do algebra with Booleans. So we're evaluating many of these very complicated expressions. These are just some very simple examples. But something I did want to mention is De Morgan's law. So De Morgan's law, De Morgan's law, it's spelled like this. And basically it says when we have not A and B, this is pseudocode, by the way. This is equivalent to not A or not B. Yeah, so when we have not, inside the not, we have an expression like A and B. We can basically factor out these parentheses by applying the not to each of the variables and then flipping the sign in the middle. So it becomes not A or B. So similarly, when we have not A or B, this is equivalent to not A and not B. Does anyone have any questions? Okay, Jeremy asked a good question. Yes, in other languages, we do use the exclamation, but the two vertical bars, I don't know what the symbol is called. The two bars in some other languages means or. So in some other languages like Java, and is the same thing as two ampersands, and or is the same thing as two of these bars. I don't know what they're called. And not is the same thing as the explanation. But in Python, we use the keywords and or not. We just spell it out. Yeah, I hope that answers your question. And if you're curious about De Morgan's law, you can check out you can try to intuitively think of some examples. Um, yeah, so this is a important part of Boolean algebra. So moving on, in Python, we also have something called membership operators. So the first one is the in operator. So for example, here's another real world example. Can we play outside tomorrow? Yes, only if you're in my team. So basically we want to check if this person is in the team. So membership operators are used to test if a sequence appears in an object. When you want to check if a given object has a value in it that's contained in it, we use the in operator. Some examples here, we can use it for a string. So here we have a word equals baseball. If base in word, this essentially means if base is inside of the word, which it is. Here we have baseball. So base is indeed a substring of baseball. Then we will print out this over here. So we can also do this with the list. We have nums equals 1, 2, 3, 4, 5, 6. If 8 in nums, print yes. So what do you think will be printed? You can say it on mute or you can type it in the chat. Okay, so this one actually would not print anything since the element 8 is not inside of nums. Nums only has the numbers 1 through 6, so nothing would be printed. Okay, so similarly over here, we can also do if x not in word. So this is basically the opposite. If it's not in it, then we will execute the code. So this is pretty self-explanatory. It's kind of intuitive. Kind of like English almost, where like not and not or in, they basically sound exactly like what they do in English. Yeah, so moving on, this is we already talked about this. Okay, so the next very important piece of decision making, we have another conditional statement called elif. Elif gives us the ability to run separate blocks of code depending on the condition. So elif is short for else if. So in the previous few examples, we're only making one decision, but what if you wanted to handle many decisions? So we use the elif statement to declare another decision based on a given condition. So that means elif statements have to be associated with an if statement. You cannot have an elif statement on its own. It has to have an if statement before that. So for this, it's good to understand the else before we talk about the elif. So here we have an if statement, followed by a condition and some blocks of code. As we know, statement 1, 2, and 3 will only run if condition is true. Now, the code outside of this whole block will run anyways. It will run regardless since it's not relying on a condition. So, but these will only run if it's true. What if we want some code to run if condition is false? Then we use an else statement. So the statements 4, 5, and 6 will only run if condition is false. Now an elif statement is the same thing as else, followed by an if. So we have another condition here. And then this would be indented. So this is simplified to just elif in Python. So that's what this is. Meaning this code will only run if the first condition is false and the second condition is true. Does anyone have any questions? Okay, if not, then I'm going to explain that. So if the first condition is true, the elif part won't even run. So once we meet a single conditional statement that returns true, all the other ones are skipped, even if they are true. So this applies for elif. So if the first one is true, we won't even consider anything after the else or the elif. So we'll jump straight to statements 7, 8, and 9. Yeah, so this is what's known as an else if statement. The code here will run if the condition is true, and the code here will run if the condition is false. So let's look at a simple example. First, we define a variable num equals 15. The question is, we want to check if the number is divisible by 2. So we have if num mod 2 equals 0, print even number. Else, meaning if this is false, then we print odd number. So I'm not sure if many of you have seen this before. I think we did talk about it in our operators in some earlier lesson. But the percent sign basically means modulo, which is a fancy way of saying remainder. So this result, num mod 2, gives us the remainder when a number is divided by 2. So we know all even numbers are divisible by 2. So if the remainder is 0, then it's divisible, then we know it's even. Else, in this case, it means the modulo turns out to be 1, it's an odd number. Since we know odd numbers have a remainder of 1 when divided by 2. Okay. So here's just another example. So let's say we have two variables and we want to compare them. We want to determine which one's greater, which one's less, or if they're equal. So we have x, y equals 10, 5. So first we can check if x is greater than y. Then we can print x is greater. Then here we have elif x equals, if x equals y, then we print x equals y. And else we have x is less. Okay, now I want to give you guys a simple problem from Code Force, and I'll give you guys some time to try to solve it. So here we have a problem called watermelon. So let's read the problem. One hot summer day, Pete and his friend Billy decided to buy a watermelon. They chose the biggest and the ripest one, in their opinion. After that watermelon was weighed, and the scale showed W kilos. They rushed home, dying of thirst, and decided to divide the berry. However, they faced a hard problem. Pete and Billy are great fans of even numbers. That's why they want to divide the watermelon in such a way that each of the two parts weighs even number of kilos. At the same time, it is not obligatory that the parts are equal. The boys are extremely tired and want to start their meal as soon as possible. That's why you should help them and find out if they can divide the watermelon in the way they want. For sure, each of them should get a part of positive weight. Okay, so let's try to do this problem. So it's basically asking, we want to check if it's possible to divide the watermelon into two parts. And each are weighing an even number of kilos. And let me know if you have any questions. I know this was kind of a lot, but it's what it's asking isn't that super long. Okay, does anyone need more time? Okay, I'll give you guys a couple more mins. Okay, so I see some good responses. Um, so since Tao answered first, do you want to explain this problem to everyone?
Sure. So first, let's see. So first, they want to divide the watermelon. So if the watermelon weighs an odd number of kilos, then you can't divide it because you can't because they don't know how to divide half a kilo. And they want both of their numbers to be even. And if they want both of their numbers to be even, it cannot be two. It has to be at least four and up and even to return yes, or else it'll have to return no. Because if it's two, the only way they can divide it is 1, and though one is odd. And for any number that's above four, that's even, you can divide it by doing the number minus two and two.
Yes, very well said. So, what he did was he set x equals int input. Yeah, so first you got the input. That's also what Jeremy did, so very nice. And then Jeremy did the extra step to check if W is greater than or equal to 100 and if less than or equal to 1. So, um, for this one, that would not be needed since what this input means is that you're guaranteed a number that's between 1 and 100, but it's good that you checked anyways. So then, like Chao said, we have a corner case here, which is that 2 does not work because if we want to split it into the sum of 2 even positive integers, we can't do that. The only way would be 1, 1. We can't do 0, 2 since it's saying that each person must get a positive weight and 0 is not positive. So otherwise, any other even number works. It says the parts don't have to be equal. If they do have to be equal, then and you want to make sure the parts are even, then there would be an extra step involved. But all other even numbers work. So very good. So now let's continue over here. So this is just try to make sense of it. We're trying to check if a year is a leap year. So commonly people think of leap years as every 4 years, but apparently it's a bit more complicated than that. Apparently you so it has to be divisible by 4 and it has to not be divisible by 100. Or if it's divisible by 400. So it's every 4 years, but not every 100 years, but also if it's every 400th year, that's also fine. So, um, yeah, that's not super important. I think for our purposes, every 4 years is good enough for a leap year. And also here, so here we have a simple grade classification algorithm. So we have a score, let's say the score you got on a homework assignment or a test, and we want to turn that numerical score into like a letter grade. So like A, B, C, or like you failed F. So over here, our cutoffs are 90, 80, and 70. So we can first check if score is greater than or equal to 90. And if it is, it's an A. And what's nice about using elifs and elses here is that once we check that it's already greater than 90, there's no need to check if it's anything less than that since we already know it's an A. So that's why we're using an elif here. Elif means else if, remember, so it will only run if the first condition is false. But since it's true, we can just print you got an A and skip everything else. So we have the similar logic here for checking if it's B or C, and if it's anything lower than 70, we print you failed. Does anyone have any questions? And also, we do not need to check if score is less than 90 in the first statement, since those are already taken care of in the elifs. Now let's talk about the main difference between an if statement and an elif statement. So one of the major differences is that going forward, the use of elif statements is sometimes better because so here it says the major difference that you'll need to understand going forward is the use of elif statements against using multiple if statements. So all else elif statements are connected to one original if statement. So if that single condition is true, the rest do not run. So this is very useful for saving time and avoiding to do unnecessary calculations. If any one of them are true, the rest of them don't run. Instead, if you use if statements for every single one of them, you would still get the correct result, or depending on which situation. But if you do this, you may get the same result, but it's a lot more time consuming. Because sometimes when we already set, um, when on the conditions is true and we can set a variable to something, there's no need to keep checking if it's going to be checking other conditions. Okay, does anyone have any questions? Okay, then let's talk about the final part, which is else statements. We already learned about this, so let's just talk about when we use else statements. Else statements are most commonly used as the final part of a decision-making process, which is like what to do by default. If none of the previous if statements or elif statements are true, then the else statement can be our default. So else statements are the end to an if statement. So after an else statement, we cannot have any more if statement or elif statements. So it just stops there. So it's the end to that one block. Sometimes you're not able to create a condition for every single decision you want to make. So that's why we can use else statements to take care of the rest. The else statement will cover all other possibilities that are not covered by your if statements, and it will always run if the program gets to it. So this means if the elif or the if statement were to be true, then it would never run the else statement. However, if everything previously was false, then the else would run every time. So Emerson asked a really great question, which is why does else statement only have the colon? Why doesn't it have a condition after it? That's because else doesn't check for one single condition. It checks if all the previous if statements and else statements are false, then the else statement will automatically take care of all the rest of the conditions. So that's why there's no one single condition you're checking. It's just anything else that was not considered in the previous if statements. Does that make sense? Yeah, okay. So, for example, over here, let's skip this one. Let's do this one. Here we want to determine if a number is positive, negative, or 0. So here we have if num is greater than 0, print positive number. Um, there should be parentheses here. Yeah. That's not super important. And then we have elif num is less than 0, it's a negative number. So what's the only case we didn't consider? If it's equal to 0. So that's why we don't need a condition here. The else will automatically, well, in this situation, it implies like num is equal to 0, but it's just the one condition that we didn't end up checking in the previous one. So it's all the other conditions. In this case, it's only possibly 0. So it will print 0. Okay. Any questions? If not, then over here, this is also something that we may end up using quite a lot, which is random. So what if you want to have a random aspect in your code? What if you want to, like, for example, generate a random number? So that's where the random package comes into play. So we have to import random since it doesn't come by default in Python. And rand int stands for random integer. So let's say we want to generate a random integer. So we can use the rand int function to generate a random integer. So we need to pass in two values here. The first one is basically we need to specify the range. Let's say we want to generate a random number from 1 to 100. So that's why we need to specify 1 to 100. And we can print out mystery to see what it is, and it should give us hopefully a random number every time. Yeah. So this is how to generate a random number. Okay, let's move on. Much of this is the same. We already talked about it. Okay, so here is a shorthand way of doing if-else statements in one line. So we have two variables, a equals 5, b equals 5. And we want to check which integer is bigger. So how can we write this in one line of code? Let's say we don't want a bunch of if-else blocks. We can actually determine the bigger number in one line using this kind of shorthand expression for a conditional statement. So we have a variable big. So we want to set big to whichever one is bigger. And so we have big equals A if A is greater than B. So this is plain English. Else B. So big equals to A if this, else big equals B. So that's what this is saying. So in this case, since they're the same, we'll end up setting it to 5, but let's do something different. It will set it to the larger of the two, which is 7. Okay, then let's try to do another problem from Code Forces. So here we have a problem called word. The question says, Vasia is very upset that many people on the net mix uppercase and lowercase letters in one word. That's why he decided to invent an extension for his favorite browser that would change the letters register in every word so that it either only consisted of lowercase letters or vice versa, only of uppercase ones, or vice versa, only of uppercase ones. At that, as little as possible, letters should be changed in the word. So it's saying at that, when we want to change all of them to either lower or all upper, we want to change as few letters as possible. So for example, the word house with H and U uppercase must be replaced with lowercase house because three of the letters are lowercase and two are uppercase. So there's more lowercase, so we change it to all lowercase. And the word VIP with all uppercase VIP. If a word contains an equal number of uppercase and lowercase letters, you should replace all the letters with lowercase ones. For example, matrix with 3 lowercase and 3 uppercase should be replaced by matrix. Your task is to use the given method on one given word. So let's try to do this problem. For this problem, a useful method to know is the um for strings, dot is upper and dot is lower. Those will check if it's uppercase or if it's lowercase. So is upper and is lower checks if they are uppercase or lowercase. And dot upper and dot lower will convert the whole thing to uppercase or lowercase. Yeah, so if the number of upper and lowercase is equal, it says if a word contains an equal number of uppercase and lowercase letters, you should replace all the letters with lowercase ones. So, Michael, in that case, you would do all lowercase. Yeah, so some useful string methods you might use is dot is upper and dot lower. Okay, does anyone need more time? Okay, so let's go over this problem then. Um, Let me open a new code block. Okay, so let's first read the input word from the user. So word equals input, right? And then, like Jeremy said, we need to have two variables to count the number of uppercase letters and the number of lowercase letters. So we can set them to 0 in the beginning. And then in the word, we need to loop through every single letter. So using the in keyword, we can loop through each letter, and then we need to check if each letter is uppercase or if it's lowercase. So if letter dot is upper, then we can increase the number of uppercase letters by 1. And else, so if it's not uppercase, then we can increase the number of lowercase letters by 1. And then after that, we can convert the word to all uppercase or lowercase letters according to which one is there's more of. So to check that, we can do if num upper is greater than num lower, then we can print word dot upper. So the upper function will convert the string to all uppercase, and otherwise we can print word dot lower. And another way you can do this is instead of doing two variables for num upper and num lower, you can have just one variable. For example, we can call it count. So also in the beginning, we'll set it to 0. And if it's uppercase, we can increase count by 1. And if it's lowercase, we can decrease count by 1. And in the end, we can check if count is positive, negative, or equal to 0. So that will also work. So here we would have if count is greater than 0, it would be the same thing. So what was the example, some of the examples they gave? Okay, let's try matrix, and we should get all lowercase matrix. Or not. I think is it all lowercase? Yes, okay. So we do get all lowercase matrix. I don't get how it moves to the next letter in the for loop. Okay, so that's a good question. Um, when we're using the in keyword, we kind of just ignore that. We don't really worry about it since it will essentially just loop through every single letter. Yeah, we kind of haven't learned that yet, but we'll talk about it in more depth when we learn about for loops. Yeah, so the last section for today is we can also have nested conditionals. So we've talked about how Python can use indentation to separate different blocks of code. And so far, we've only seen one level of indentation. But what happens if we add an if statement inside another if statement? Okay, so here we have some examples. Okay, so let's use the first one. We have age equals 18 and weight equals 50. So very random example, but we want to know if this person is allowed to trek. Okay, so if age is so in order for them to be able to trek, they have to be over 18 years old and they have to be heavier than 50 pounds or probably kilograms. That would make more sense. So here we can first check if age is greater than 18. So they have to be 18. So that's why outside of this big if statement block, we have else. We just straight up tell them they have to be over 18. And in here, we can have a nested if statement to check. So we already know their age qualifies, but in here, we can check if their weight also qualifies. So that's what this conditional, nested conditional looks like. So it works pretty much the same as a single conditional. Does anyone have any questions? Okay, then. Okay, so I think we'll stop there for today. We can work on this project maybe next time. And also, if you guys want some practice problems for conditionals, you can let me know, or I can try to email some practice problems to you all. Okay, so we'll stop here for today. Thank you all for coming.